Hello everyone, in today's lesson we are going to cover section 4.6, slope. After studying this section, you'll be able to understand the concept of slope, relate the slope of a line to its orientation in the coordinate plane, and recognize the relationships between the slopes of parallel and perpendicular lines. So first, looking at the definition of slope. To understand how the principles of coordinate geometry can be applied to the study of parallelism and perpendicularity, you need to be familiar with the concept of slope, which you probably talked about in previous classes. Now, the slope m of a non-vertical line, segment, or ray containing the ordered pairs x1, y1, and x2, y2 is defined by the formula m is equal to y2 minus y1 divided by x2 minus x1, or m equals y1 minus y2 over x1 minus x2, or m equals the change in y over the change in x. You've also probably heard it refer as rise over run. We want to figure out the change in my y coordinates and divide that by the change in the x coordinates. It doesn't matter the order that I subtract the coordinates in as long as I am consistent. What I cannot do is subtract y1 from y2 and then subtract x2 from x1. I need to be consistent where if I subtract the first y coordinate, then the first x coordinate has to be the first as well. Now looking at the four different types of slope, when I look at a graph, I read my slope from left to right. So if my slope is increasing from left to right or a rising line, this is a positive slope. If I'm decreasing from left to right or a falling line, this is a negative slope. If my slope does not increase nor decrease, this is a horizontal line, which is zero slope. And then if my slope has a rise but does not have a run, this would be no slope because I can't divide by zero. So a vertical line has no slope. Now looking at slopes of parallel and perpendicular lines, I have two theorems for parallel lines and two theorems for perpendicular lines. If two non-vertical lines are parallel, then their slopes are equal. And the converse of this theorem, if the slopes of two non-vertical lines are equal, then the lines are parallel. Because I know parallel lines will never touch, meaning I have to increase by the same amount for each line in order for them not to touch. And then perpendicular lines are opposite reciprocals of each other. So if I have the slope 2/5, the opposite reciprocal of 2/5 would be -5/2. Again, two theorems of perpendicular lines. If two lines are perpendicular and neither is vertical, then each line's slope is the opposite reciprocal of the others. And if a line's slope is the opposite reciprocal of another line's slope, then the two lines are perpendicular. Now looking at our sample problems, we have problem 1. If a equals 4, -6, and b equals -2, -8, find the slope of line AB. So if I want to find the slope, I want to find the change in y over the change in x. So I'll take -6, subtract that from -8, which will make +8. And then I'll take 4 and subtract that from -2, which will make +2. -6 plus 8 would be 2. 4 plus 2 is 6. 2 divided by 6 is 1/3. So the slope of line AB is 1/3. Problem 2, show that CEF is a right triangle. Now, in order for it to be a right triangle, it has to have a right angle. I know if two lines are perpendicular, they form right angles, and perpendicular lines have opposite reciprocal slopes. So if I find the slopes of each of these lines, and if any of them are opposite reciprocals of the other, then this is a right triangle. So if we first find the slope of line CF, this would be 3 minus 7 over 1 minus 4, which would be -4 over -3, which would be 4/3. If I find the slope of FE, this would be 7 minus 4 over 4 minus 8, which is equal to 3 over -4. Notice these two lines right here have opposite reciprocal slopes. Therefore, without even showing what the slope of CE is, I know it's a right triangle. Looking at problem 3, we're given triangle ABE is shown. I want to find the slope of altitude AC and the slope of median AD. Now first, if I want to find the slope of altitude AC, I would drop an altitude from vertex A. That would be perpendicular to line BE. So if I find the opposite reciprocal slope of line BE, that would give me the slope of the altitude AC. So BE, this line's slope, would be 5 minus 3 over 6 plus 4, which is 2 over 10, which is 1/5. So the slope of AC would be the opposite reciprocal of 1/5, which would be -5. Now looking at the slope of median AD, if I drop a median from vertex A, it would go to the midpoint of line BE. So I need to find the midpoint of line BE, and then I can use coordinate of A and this coordinate D to then find my slope. So D would be 1, 4. Now I can use these two coordinates to find the slope of my median AD. So I'd have 4 minus 10 over 1 plus 2, which would be -6 over 3, which is -2. So my slope of my median is -2. Looking at problem 4, find the slope of line AB to the nearest hundredth. Here I'll have 2 root 5 minus root 5 over 6 minus 3. 2 root 5 minus root 5 is just root 5. 6 minus 3 is 3. Root 5 over 3 is approximately 0.75. So the slope of line AB is approximately 0.75. In today's lesson, we learned to find the slope of a line, we calculate the change in y and divide it by the change in x. Parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. That's a wrap on today's video. We'll see you in the next one.